Here's problem 9.9. A 6 kilogram object moving 5 meters per second collides with and sticks to a 2 kilogram object. After the collision, the composite object is moving 2 meters per second in a direction opposite to the initial direction of motion of the 6 kilogram object. Determine the speed of the 2 kilogram object before the collision. Alright, so we have one object, let's call it mass 1, 6 kilograms. It's moving at initial speed, one initial, of 5 meters per second. It's going to collide with mass 2, which is 2 kilograms. And that's moving with a velocity that we don't know. V2 initial, we don't know. It's evidently moving to the left, though. This is the way things are happening initially. Then afterwards, the two of them have stuck together, and they move with a common velocity, v final, which is actually a speed of 2 meters per second, but since it's moving to the left, would be a negative 2 meters per second for a final velocity. Total mass, in this case, 8 kilograms as they move together. And this is the way things look like finally. Well, it's a perfectly inelastic collision, and kinetic energy will not be conserved, but with all these collisions, momentum will be conserved. So we have our one equation to rule them all for momentum, mass 1, v1 initial, plus mass 2, v2 initial, equals mass 1, v1 final, plus mass 2, v2 final. This will always be true for all of our collisions. In this particular case, they're going to stick together, so v1 final and v2 final will be the same since they're moving together. So this is going to equal mass 1 plus mass 2 times v final for a perfectly inelastic collision. Based on our numbers, we have mass 1, which is 6, v1 initial is 5, plus mass 2, which is 2, v2 initial, we don't know, that's what we want to find out, is equal to mass 1, 6, plus mass 2, 2, moving with a final velocity of a negative 2. Solve this for v2 initial. So we have v2 initial is equal to 8 times a negative 2 minus 6 times 5, everything divided by 2. Negative 16 minus 30 divided by 2, which would be a negative 46 divided by 2, or negative 23 meters per second. So our initial velocity for mass 2 is a negative 23 meters per second. In other words, it's moving 23 meters per second to the left. If we were trying to determine the speed of the particle, which is the magnitude of the velocity, then we only need to know that's moving at 23 meters per second. So that's our answer for the speed. Our speed is 23 meters per second.